Ingenuity represents the most remarkable things that humanity is capable of. These achievements are not just the product of pure determination, they're a combination of human perseverance and ingenuity.
Hi, Vanessa. My name is Mimi Ong. I work at NASA Jet Propulsion Laboratory, JPL, and my job there is project manager for Mars Helicopter. Mars Helicopter is a technology demonstration flight experiment that Mars 2020 Perseverance rover is hosting. And we're going for the attempt at flying the first ever flight on another planet. So I've been really excited about this phone call to talk to you because I'm getting to share with you the news that your proposed name has been chosen as the name for Mars Helicopter.
Wow, that's amazing.
So on behalf of our entire Mars Helicopter team, I'd like to thank you for our name for our Mars Helicopter, Ingenuity. It's the perfect name for us. We love the name, so thank you.
Thank you, guys. Ingenuity is what allows people to accomplish amazing things, and it allows us to expand our horizons to the edges of the universe.
Hi, I'm Raquel Villanueva with the news team at NASA's Jet Propulsion Laboratory in California. Hitching a ride on the Perseverance rover launching to Mars this summer is the Mars Helicopter, which now has a name, Ingenuity. Now, we want to give you a chance to learn more about this experiment, as Ingenuity will try to be the first powered flight on another planet, and we are following social distancing rules. That's why Mimi Ung, the Mars Helicopter project manager, joins me from the Mars Helicopter Test Lab at JPL. She's the only person there. The helicopter is in Florida awaiting launch, and I have a couple questions to get us started, and then we'll be asking Mimi questions submitted with the Ask NASA hashtag. Mimi, thanks for answering our questions today.
You're welcome. Thanks for having me here.
Of course. So to get started, how does a helicopter work on Mars? I see you have a model behind you. Can you kind of explain it using that?
Sure. This is a full-scale model behind me. The helicopter has a solar panel on top with a communication antenna. Right underneath is a rotor system. It's a pair of counter-rotating blades that will spin up to about 2,400 revolutions per minute, very fast. And underneath is the fuselage containing the battery and special electronic boards, thermal components, sensors, cameras. And at the very bottom is the landing gear. The entire vehicle weighs about 1.8 kilograms, just about 4 pounds.
Wow. And can you talk about the teamwork and innovation that took place to get this project off the ground?
Yes, building for the first time a helicopter that can fly in the very thin atmosphere of Mars was considered to be almost impossible, definitely really challenging. So to have a helicopter that can fly in the thin atmosphere autonomously and survive autonomously on the surface of Mars and to be operable, all the way back from Earth, that took ingenuity, hard work, and really true teamwork from many disciplines. There is a significant team behind the making of the Mars helicopter. I really wish everybody on our team is here today to share our stories with you, but I'm really proud to be representing the team here from, all the way from the mathematical equations that represent the helicopter to software, electronics, mechanical structures, thermal, power, materials, special fixtures, special facilities that it takes to test. It's a very long list of technical specialty that it took. And to meet these challenges, we work together really tightly, both technically in each discipline and as a system together to make this work. And we're a really tight team. We are really happy to be where we are today, ready, integrated onto Perseverance rover for launch to Mars for that very first test flight at Mars.
And you were just touching on this now. The Mars helicopter is riding on the Perseverance rover. So how does the idea of perseverance work with the idea of ingenuity for your team?
A Mars helicopter called Ingenuity on a rover called Perseverance. How much more perfect can it get? You know, Mars helicopter is a first of a kind system that's going to attempt the very first flight of a helicopter on another planet, right? Very much like a Wright brothers first test flight moment. And it took ingenuity, hard work, and definitely perseverance to get to where we are today. And here we are, Ingenuity helicopter integrated on Perseverance rover for launch to Mars for that very first flight test on the surface of Mars.
And I heard that the team found out about the name this morning. How did it all go?
Oh, it was incredible. A big part of our team, a subset of our team, got together, and we got to have the name shared very shortly, before the announcement. We had it shared by the student, Vanessa, that wrote the essay that inspired the name, and it was an incredible experience. It's an extraordinary moment for our team, really. It's been a very tough, challenging journey. Our team has been just inspired by this opportunity, this chance to build a first of a kind system that will introduce the aerial dimension to the way we do deep space exploration today, right? Ability to fly in the atmosphere of another planet or another planetary target. And so we've been really driven by all of this over the past 5 or 6 years. And this is definitely one of those extremely special moments where we have a name, for this helicopter that we've been working so hard on. I kept saying throughout the whole event, the meeting, though, that one thing I really wish was that I could have been in the room in person with everyone in the team, but with the current situation, it was done through remote meeting. But I really wish that I could have been in the room with everybody else. We're just such a tight team, and I really wish we could have been all together. Nevertheless, it was a great event. I'll never forget this day.
Oh, that's so great to hear. Now, thanks for answering my questions. I have some Ask NASA questions to ask now. The first one, it's very similar. Juan, AJ, want to ask what Daniel is asking. What are some of the difficulties when designing airborne machines for use in other atmospheres when compared to Earth's? And is there a way the NASA team can simulate Mars-like environments on Earth for testing?
Yes, definitely. Flying a helicopter for Mars in this very thin atmosphere, with a different Mach number and Reynolds number combination, just a different atmospheric composition and very different atmospheric density, turns out to be quite different from designing a helicopter for Earth. And so the team had to go back all the way to the fundamentals of modeling the lift and the drag of a blade, really optimize it, and then develop a helicopter around there. It has to be very light. As you know, our helicopter weighs about 1.8 kilograms. It has to spin extremely fast, about 2,400 RPM. So the very first challenge was to meet that stringent mass constraint to fit all of the autonomous capability, autonomous flight, autonomous survival, staying warm through the cold night, being able to communicate, being able to charge itself, through the sun and storing the energy and having enough energy to survive the cold nights and flying. Coming up with a design with those constraints, that was the first challenge we overcame. And then second is to build and test it. In terms of the environment to test on Earth, we utilize a special facility called the Space Simulator Facility, a chamber. It's a special chamber at JPL. It's a 25-foot diameter chamber that can be pumped down to vacuum. And what we did was we pumped that vacuum down to near vacuum, backfilled with carbon dioxide to represent the Martian atmosphere, and performed our test flights there. One thing that we can't compensate on Earth is the gravity. The gravity on Mars is significantly less than on Earth's, right? Like about 40% compared to Earth's. So we did add a gravity offload just to offload the helicopter at a consistent, difference to make up for the different gravity.
Yeah, that's the question everyone wanted to know. And now I have one from Brian M. Malloy from Facebook who asks, how long can Ingenuity sustain flight? Does it solar charge or return to the rover to dock and recharge?
Yes. So Ingenuity can fly up to about 90 seconds. That's how we've designed it for this first of a kind vehicle. This is a small proof of concept vehicle. So for this vehicle, we have designed it to fly up to 90 seconds. We can, in that distance, we can do up to about 300 meters round trip in that. And if the vehicle has a solar panel, and it will be recharged through the solar panel, and will be storing the energy in the batteries and supplying the energy. So it's the ultimate green machine. It's powered by solar energy. We store the energy, and we kind of apply the energy for flying and surviving at night. So we will not be going back to the rover to recharge. In fact, once Perseverance rover delivers us to the surface and drives away, we never will be returning to the rover. Instead, we'll be communicating wirelessly. The helicopter will communicate wirelessly to the base station that we have left on the rover, and the base station will talk to the rover, which will relay the messages back and forth to the helicopter.
And we kind of have another question about survival on that. Bumble on Twitter actually asks, what about the storms on Mars? Will the helicopter blade survive this?
Yes. So this helicopter is designed to be able to fight the winds up to 9-10 meters per second during flight. And those are lower speeds than those are, let's see, our vehicle is designed to fight the worst predicted wind level. Okay, so definitely the controllability of the blades, the way we have structured the rotor system matches the worst predicted wind, and with margin on top of that. Okay, so it will be flying during the well-known conditions. And then while it's sitting on the surface with the legs, feet firmly planted on the ground, it can take even much higher winds because the dynamic pressure in the atmosphere of Mars will actually be much less. So it'll be able to take much higher level of winds. So yes, we very carefully design the helicopter to take on the winds that we expect to encounter.
Yeah, in that regard, what steps will happen once it lands on Mars? Are there going to be certain milestones it has to hit?
Yes. So Ingenuity is the very first flight test on Mars. Remember? So very analogous to think of the Wright brothers' very first flight on Earth, except we're going to do it at Mars. So on Earth, we have tested the Mars helicopter all that we can in the simulated environment that we just discussed. And the next step is now to perform this test the helicopter in the environment that we've designed it for, in space and at Mars. So with that, the high risk but very high reward flight experiment that we're going for at Mars, and we have a checklist of milestones that we will be looking for, checking off, and learning every step of the way. So the first step will start with surviving the launch and the trip to Mars and getting to the surface, and getting deployed to the surface of Mars and confirming our first communication from the helicopter to the base station on the rover. And then surviving that first cold night autonomously. The temperatures are very cold, minus 90 degrees Celsius in the nighttime at Mars. Surviving, the helicopter standing on its own, surviving that first night is a major milestone, a big check mark we'll get. Confirming that we're charging through the solar panel and garnering the energy, a big check mark. Then the very first spin on Mars, and then the very first lift, and then the very first flight, and the very first landing. And then after that, we'll be repeating the flights within the 30 Martian sols that we have available to us for our flight experiments. So we are really looking forward to learning every step of the way, going across our checklists incrementally and very systematically. We're really looking forward to learning from every single step.
That's great. And Alistar on Twitter has a question kind of looking into the future. If this is a proven method of exploration, could it be used more and in greater numbers?
Oh, absolutely. This is a first of a kind proof of concept technology demonstration flight to show that we can fly and operate a helicopter at Mars from Earth, right? And like you say, it is just the Pathfinder. And our team has been working really hard over the 5 years because of that motivation to introduce the aerial dimension. Once we've proven it, our dream is the future, larger, more capable vehicles that are more autonomous, much longer flight times, carrying larger payloads. You know, we're imagining this is a 1.8 kilogram system. We can imagine 10 kilogram plus systems carrying, 1 to 2 kilograms of payload, very specialized payload to serve as scouts for rovers, getting high definition images before the long traverses, and reconnaissance for astronauts for exploration at Mars when humans start to explore in person over there at Mars, right? In addition, aerial vehicles will allow us to get to areas that we simply cannot access today. Rovers cannot get to sites of very steep cliffs that are areas of interest to us, or very steep volcanoes that we cannot get into. Being able to fly about will enable us to extend our exploration through the aerial dimension, complementary to how we explore on the surface with rovers and spacecraft in orbit today. And you can imagine, the audience can imagine, the next generation, you must imagine. So our team is simply introducing the aerial dimension, where we are really extraordinarily proud and really grateful for this opportunity to get a chance to show how we would fly. But it's really up to future generations to take flight, literally, in the aerial dimension.
That's great. Thank you so much, Mimi, for answering our questions. And thank you for all the Ask NASA questions. Thanks again.
Thank you.
Now, Perseverance, with Ingenuity on board, is set to launch from Cape Canaveral, Florida this summer, and it will land on Mars February 18th, 2021. And in the Learning Space section of the JPL website, we have some fun hands-on projects to share with you. Now, if you have kids at home, you can make your own paper helicopter. And you know what? It actually works. Check this out. You can fly just like they can at home. And you can explore the red planet like the Mars Ingenuity helicopter will by learning to program a video game. Now, all the projects are available at jpl.nasa.gov/edu/learning-space. And you can follow the helicopter's journey on social media by following @NASAJPL. Thanks for watching.